For now, we're going to assume that you know basic CAD modeling and how to get your part from idea into a CAD model. Don't worry, we will touch on modeling for 3D printing in a later video though. So let's export our part out of CAD into an STL file, or stereolithography file. This is a file type for a 3D model that is kind of the standard in 3D printing. It is pretty much universal in that nearly every CAD software will export to an STL, and once you have that STL, nearly every slicer will accept an STL, and the slicer is the software we're going to be using in the next step. So what is an STL though? When our model is in CAD, things are defined exactly as they are. For example, this disc here. The circle that makes up this disc is mathematically defined as a perfect circle. However, the slicer that we'll be using in the next step does not run on these perfect mathematical representations. It needs a discrete model. And a discrete model uses some sort of building blocks instead of pure math to build a representation or an approximation of our model. And in our case, STLs use a 2D triangle as a fundamental building block to build a three-dimensional shape. So we have these triangles in three-dimensional space called facets. And if we connect a whole bunch of them together, we can construct a three-dimensional surface. And this is all an STL, is it's a whole bunch of triangles strung together in a mesh that will represent the part that we've modeled in CAD. Alright, so this is our part all modelled up in CAD. Now we're using Onshape, but the process is pretty much the same across different CAD modelling suites. First, we are going to export the part that we want. Then in this export window, we're going to name our part. Select STL as the file format. Ensure we chuck it into binary. And then select millimeters as the units. Always ensure you work in the same units across the whole process. It will save you a lot of hassle. Then we want to set the resolution or detail setting to as high as we can possibly export it. Then just hit export and we are done. Let's go over a few things though. If we open our STL, we can see that it is nice and smooth and that it is made of triangles. Oh, look at that. Now here is one I exported at a lower resolution and we can immediately see it is a bit rough. And that's because the low export settings uses less facets to construct our model. And this means we have a worse approximation of our CAD model. And as you might guess, this low polygon count STL can really hurt whatever we're trying to print because it is not going to be dimensionally or geometrically accurate. So always export at the highest possible resolution you can because the low poly one was only 20 kilobytes and the ultra high resolution one was 80 kilobytes. One more thing, STLs are nearly impossible to edit. By exporting, you have discretized your model at this point, and really the only easy thing you can do is scale it to be bigger or larger. For example, if you wanted to extrude this face out a bit more, you would have to manipulate all these triangles in the mesh, and that is not fun nor easy. So if you wanted to redesign a part, you need to go back to CAD, make your changes, and then re-export as an STL.